Hey guys, welcome back. Well, it's finally here. My new Syncmode V2 frame from Superfly. So this is not going to be a review video. I purchased this frame with my own money. I'm going to fit it out, and this is actually going to be my new freestyle frame for what I call open air freestyle. So in this video, I'm going to build the frame, we'll fit it out, we'll talk about the design choices along the way and what sort of motors, flight control and so on I'm using. And basically that's it. You're going to sit there and have a coffee. I'm going to build the frame. But let's get started. Okay, well, let's take a look at the parts you get in the kit. Okay, we've got some stickers down here. It's always nice when you get stickers. I like that. You get 2 battery straps, which is really good. You get a battery mat. I'll talk about that later in the video for sure. Okay, we've got some, I'm going to go into this. You get more screws and bolts and nuts and everything than you need. That's all there. Side plates, the arms look like this. All the arms are identical, by the way. Okay, I really like the finish on this, the blue finish. You can choose blue or pink. And I like the fact that they've actually countersunk. You can see there, they've actually countersunk the chisel head bolt places, as well as having these bolt insets here, so it makes it very easy just to screw them in. Right, now when you order this kit, you actually order the TPU parts that you need. So in my case, I've just chosen this antenna holder here. You can choose different ones. I've chosen my camera mount for my camera, and I actually chose these bumpers here that go on the side plates. So, you know, once again, when you do the ordering process, you just choose which TPU parts you want to come with your kit. And yeah, it's a really good idea. Okay, so we'll have a bit of a closer look at the frame, and I'll tell you exactly why I chose this frame. Now, first of all, the geometry of the frame. You can see this is a TrueX frame. It's not a TrueX, it's a squished TrueX. I much prefer the way these fly compared to a dead cat frame. So I'll always go for the TrueX frame or the squished X frame if possible. I also like that this is a slam tight frame. So you can see the height of the frame is only 20 millimeters. That's the internal gap in the frame. Most frames are 25 millimeters at least, or even more, 25 to 28 millimeters. But this one being a 20 millimeter height frame, it gets that battery down nice and low and keeps all of the mass down low, which also helps with the flight characteristics. You might also notice the body, the length of the body. So this is actually quite a short frame. Okay, so it's very compact. And once again, yeah, centering that mass in the center instead of spreading it out. If we compare this to another frame like maybe a Nazgul or something like that, you can see how spread out the frame is, how long the frame is. And you've got the VTX way down the back and the camera way up the front. And I mean, that's great for building. Plenty of room in there for building and fitting out things. But I much prefer a more compact and centralized mass in the frame. But of course, it's going to be giving us some challenges for doing a build. And that's something we're going to get into in this video. We're going to look at what considerations we're going to need to make to fit out this frame. Okay, so first thing I'd like to do is put the frame together and just see what gaps and tolerances we've got to fit all the components out. Okay, so I'm using the 30 by 30 mounting holes here in the frame. And one thing I like about this frame is that it's an all-in-one bottom plate. It's not a split deck. Split decks are great, but when you've got a slam frame like this, the all-in-one plate is, of course, it's a bit of a necessity, really. You need it, so you've got that height in the frame to put the stack. Okay, so there we go. You can see it's nice and flat here. Now, if you looked at the arms before and you thought, aha, there's a problem here, because most of the time when we look at the arms, we're used to seeing a gap up the middle of the arm here, and that slides in, you know, and clears the frame standoff. But these ones don't have that gap, that slit up the middle there. They've just got the 2 holes here, this hole on the end and this hole here to hold the arm in and to bolt the arm in. So the arm actually slides in over the top of that frame, the standoff bolt. Okay, so it slides in over the top of there. So where's my base plate? The cover. Okay, so it slides in there. So if you need to remove an arm, you just take out those 2 screws and slide it out. And the fact that it slides in nicely over that bolt head there just makes it nice and easy. You can still access that bolt head through these holes, whether it's the 30 by 30 or the 20 by 20 mount you're using. Okay, that's a really good idea. Okay, so we'll just continue and put the rest of the arms on. And I think this is a good idea. The arms just butt up against each other. We don't have that keystone piece that a lot of frames have in the middle of the arm to hold them in place. The frames just butt up against each other, and I think that's a lot better, but there's less joints and less movement. Okay, and that's how it looks when the arms are attached. Okay, so at this stage, let's have a talk about arm protection. So with this frame, I didn't actually order the TPU parts for the arms, the arm boots, when I ordered it. I don't usually like to use them. In the frame, in the kit, it actually comes with these foam parts here. Let's have a look. Okay, so we got these foam pads, and yeah, that's not my favorite way of doing it either. So what I like to do is actually something like this. Let's have a look at how I've done it on the bottom of this frame here. Okay, so you can see on this frame here, I've got these alloy standoffs, and these are actually cup head bolts, cup head standoffs, and the bolts go down there. See if we can get a bit of a closer view. Okay, so you can see what I've used here is some cup head alloy bolt seats, and these are block head bolts. And you can see they've been worn down to the top of the bolt head, but it offers a lot of protection that won't wear down a lot more. Okay, so this is a 3.5-inch frame, but for this one, what I'm going to do is use these M3 cup head. Let's have a look at them. Okay, so these are M3 ones, and you can see instead of using a block head bolt, I'm using just the cap head bolt, and that sits down nice and deep in there. Okay, so I'm actually going to put them on these outer positions on the frame here, and that's going to be what I'm going to be sort of landing on and give some protection instead of using the arm boots or these foam things. Okay, so that's the 4 attached there. So when we put the frame down, we get this kind of effect. So it gives you a decent gap underneath the frame. Okay, and just as a bit of a side note, I am using this Loctite 243 on all of my threads and bolts. I'm not showing it in the video just to save a bit of time, but what I'm actually doing is putting this on with a matchstick, just a little bit on the thread, and then tightening it up. Okay, so here's a question. If you're designing an FPV frame, and you're going to drill holes in the back here for a 20x20 VTX mount, would you use M2 holes or M3 holes? Well, this frame has got M3 holes. 20x20 M3 mounting. As far as I know, the only VTX that uses M3 20x20 mounts is that Walksdale V3 or something like that. And so it took me a while to figure out the reason why, and I'll show you why. Now, when you're ordering this kit, you can choose the accessories you want to come with it. And if we scroll down here, one of the accessories is the video transmitter mounting. And this one here called the Vista isolated kit is the one I should have ordered. And that looks a little bit like this. So this is the isolator mount here. You can see these parts here fit down in those M3 holes. And this hole here is an M2 hole. So this is the part I should have ordered when I ordered the kit. Well, that's great. Somehow, I've got to make these M3 holes into M2 holes. And I know just how to do it. I'll show you what we're going to use. These are M3 to M2 adapters. So you can see that these basically are M3 on the outside and have an M2 hole on the inside. They'll fit neatly down into the holes in the back of the frame here. We can just plug them straight in. So now the M3 holes in the frame will become M2 holes, and we can just mount our VTX as normal, like so. So at this stage of the build, I just like to get all of the VTX mount bolts, as well as the flight controller mount bolts set in the frame, so we can look at all of our components and see how we're going to lay it all out. I'm also going to partially construct the camera cage, just so we can see how much room we've got up front for mounting. Okay, so that's enough of the frame constructed so that we can now look at component spacing and positioning in the frame. So let's talk about components. Okay, and the selection of components looks like this. Okay, and first off, I'm using the Vista unit and an ELRS receiver. But anyway, for what that's worth, you use what you use. Okay, let's have a look at the flight controller. So on this build, I'm using the HGLRC Specter 460. Now, this is a 30x30 flight controller, and I'm basically just using this one because I happen to have plenty in stock. And the thing I like about this flight controller is that it's got a nice low profile, and it'll be good for this frame with the limited amount of space. It's got all these connectors here, so you can do plug and play if you want to, but I'm just going to be soldering straight to the board. You can see that all of the pins are broken out here, and we've got some nice silk screening on there too. So for the flight controller, any 30x30 stack will do you well for this build. Whether it's HGLRC or T-motor, just choose a reputable brand. But the thing that's really going to define your flight characteristics is the combination of motors, battery, and props. And for the motors, I'm using these. This is the iFlight XING. It's the 2306 and 1700 kV. So for most 5-inch builds, instead of this 2306 size motor, you're going to use something like this, a 2207 size motor. And the 2207 size motor's got a taller stator, which means it's going to spin up and slow down faster as well. And when you do put the power on, that power is going to come on quickly. And that's what you want for bando bashing or proximity freestyle like you're seeing here. But that's not the sort of freestyle I'm going to be doing here. With this Syncmode V2, I'm going to be doing what I call more open air freestyle. So open air freestyle is where you're flying in much wider open spaces and still doing proximity around trees and things like that, but also more focused on the horizon and doing freestyle in open spaces. And for that, the smaller stator volume of the 2306 size motor is actually going to be an advantage. Now, I mentioned before that I'm using these 1700 kV motors. Now, 1700 kV is probably a little bit on the low side for 5-inch freestyle on 6S. Most of the time, you're going to be looking at 1800, 1900 kV. So for these 1700 kV motors, I'm going to pair them with this prop here. This is the HQ J37 prop. It's not a 5-inch prop, it's a 4.9-inch prop. And this prop here only weighs 3.4 grams. So the weight of this prop, combined with it being a 4.9-inch prop, is going to help keep our tip speed up on the 1700 kV motor. For the battery, I'm using this 1100 mAh 6S battery. Right, so let's look at the frame now and our component fit out. Look at the spacing we've got in the frame. I'm basically just going to put my VTX in the back here. Again, the camera is just going to run through there. I'm going to take the camera cable below the 4-in-1 ESC, so I'm going to run that there. Okay, so we put the 4-in-1 ESC in here. Okay, we can then see how much room we've actually got in the stack, in the frame. Okay, and I'm looking at this amount of space here. Now, with this build, I really want to put a capacitor, and if I can, a spike absorber in too. But if we have a look at the space we've got in the frame, to zoom in a bit, and if we look at the space we've got in the frame and the size of this capacitor, it's going to be very hard to fit the capacitor in there. Okay, that's where we want to have it, ideally. We want to have it as close as we can to these battery pads. Okay, so in this situation, and if I have a look at the height of the frame here, and the height of the capacitor, the size I have to use, mounting it vertically is not going to be an option either. Right, as I said before, we're going to have to make considerations when building such a tight frame. One thing we can do is actually turn the flight control around, like this, and mount it so we have the battery leads coming out the front here. Let's just put the top on and have a look how that's going to work. Okay, so with the top plate on, and also I'm using a GoPro session, so I'm just going to put the session mount on here too. Right, so if we think about having the battery leads come out this little gap here, you can see there's a little gap there in the frame that they've made for the battery leads to come out. So if we think about that with the GoPro session mount on here, the battery is going to be sitting way back here. And it's going to be very hard to actually get that connector in there. Okay, so for this build, I don't really think that's going to be an option, turning the flight control around and having the battery leads come out the front. Right, so we'll actually have to mount the flight controller the standard way with the battery connectors at the back here. And we're going to have to think about something to do so that we can fit the capacitor and the spike absorber in. So for this frame to fit the capacitor in, I'm going to actually have to run some leads from the battery terminals up to the front here, and it's not the best solution. Of course, the worst case scenario is actually mounting the capacitor on an XT60 like this here, and that's pretty much next to useless. The most effective way is to put the capacitor right on those battery terminals there. So where I'm going to put it up the front here, I guess you could say it's halfway between next to useless and effective. So that's what I mean when I say we're going to have to make some considerations to build such a tight frame. And so I'm going to do that. I'm actually going to run some leads up there and mount this capacitor up in here in the cavity behind the camera cage. Now I'm going to actually be hard mounting my 4-in-1 ESC. I don't know if you've realized, but in the last 3 to 4 years, it's become quite a trend to soft mount the 4-in-1 ESC. In fact, manufacturers have gone to exactly what we see here. We've got a 4mm hole in the 4-in-1 ESC, as well as the flight controller, and they supply dampeners that go in those holes to convert them to M3. But of course, this is not the way it always was, and actually you don't need to soft mount an ESC. There's nothing in there that's going to be affected by vibration or resonance or anything like that. In fact, the only reason we soft mount the flight controller is because of the gyro. So if we have a look at a flight controller from a couple of years ago, so here's one here, this is a 20 by 20 stack. We can see the flight controller's got the M3 holes for the dampeners, and the ESC has just got basically the M2 holes there, and that's a hard mount. And then most recently, we've gone to this model here, where we've got the M3 holes in both the 4-in-1 ESC as well as the flight controller. And I guess maybe it's a good idea, maybe it guarantees the correct spacing, although not in this case. It doesn't seem to help at all. But I'm not sure why manufacturers have gone to this model, but I don't do that. I still hard mount my 4-in-1 ESC, and that's what I'm going to be doing on this build. And to do that, we're just going to use similar adapters for what we use in the VTX mount. These are, in this case, M4 to M3 adapters, and they look like this. So you've got the M4 on the outside, M3 converted to M3 on the inside. And they just go straight onto those M3 bolts, and that converts the M4 hole to an M3 hole. Okay, straight down like that. So now we've got hard mounted 4-in-1 ESC. At this stage, I'm just looking at spacing in the stack and working out what sort of spaces I'm going to need in the stack, as well as underneath the VTX. For example, in my case, I'm going to run the motor wires underneath the VTX, so I'll need spacing there as well. And what I usually end up with is just taking a photograph or making a map like this to show what spacing I'm going to need in the stack and how I'm going to build the stack out. Okay, so let's get soldering. Okay, and let's stop right there. What am I doing wrong? Can you see the two mistakes I'm making here? The first thing I'm doing is using this fine tip soldering iron, and that's not going to get enough heat into this pad here, or any of these pads on the 4-in-1 ESC, to do the solder quickly enough. What I need to be using is one of these very coarse tip soldering irons. Okay, so this thing is going to get the heat into the job quickly, so we can get there onto the pad, get the soldering done, and get off before the whole 4-in-1 ESC heats up too much. Also, for the solder, instead of using 1mm solder, I'm going to use 1.5mm solder. Okay, this is going to allow me to feed the solder in very quickly and complete the soldering joint. Or in this case, I'm just tinning the pad, but I'm going to be able to get in and get that done quickly. Don't forget to put a little bit of flux on as well, just a little bit. Okay, a tiny bit of solder there, just to get some contact and heat into the pad. Just let me turn my fan on. I always use a fan when you're doing soldering. Okay, let's heat the pad up, and then feed the solder in, and we're off. Once again, got a little bit of solder there to make a connection and get the heat into the pad, so we'll just heat the pad up. Solder goes directly onto the pad, and off. Okay, so that way it's all done before the ESC heats up, and I can actually hold my finger there, and it's not hot at all. So we're looking at the underneath of the board here where those wires are going to run up to the front to the spike absorber and capacitor. The battery leads, they're actually going to come out these holes here in the back here. You can see I've drilled some holes in the TPU mount there, and I've left enough space underneath the VTX so that the battery wires, the battery leads can fit underneath there. So they're going to come through this way, but to get them down onto the frame, I need to make a little bit of a bend in here like this. Okay, so a little bit of a bend in the wire like that before I solder it up. And before I tin it, because once I tin it, the solder is actually going to wick back into the core here, and for about a centimeter you won't be able to bend it at all. So I'm going to bend it like this first before I tin it, and that will go on there like that, and it will sit down flat onto the frame and run underneath here. That's with those wires soldered on there. Let's put the ES41 ESC in place. Okay, VTX goes straight over the top. And we'll just have a look at how the wires go underneath the VTX. Okay, so you can see, there we go. Let's get a good angle. Okay, so you can see there the wires go down and underneath the VTX at the back here. Okay, once we get the wires in position for the spike absorber, we can just cut them to length and solder them. Now I'm just using arm tape here, just cutting to the right size, and we're going to wrap the whole bundle up in arm tape and then secure it to that standoff, the frame standoff there. And we'll just cinch that down nice and tight with cable ties onto the frame standoff. Right, and for the wiring on this, I'm actually using this here. This is called parallel line. And with parallel line, the silicon's actually joined together. So you've got 4 pieces of wire joined together. Okay, so there's the 4 strands of wire there. They're all joined together. You've got a white line down one end there, on one side, so you can orientate it. Okay, so that's what I've used for the receiver. The receiver is up the front and comes into these pads here on UR5, and then for the VTX down the back, I'm going to have them coming in here onto that TX1 UR1. Okay, so the parallel line looks a lot neater than having individual strands of colored wire, but you really have to watch your wiring and make sure you don't cross wire anything. Now I'm going to be using the GoPro session with this one, And this is a mount that you purchase when you purchase the frames, just a TPU mount. If we have a look at this, so we can see that these two holes here go on the frame standoffs here on the camera cage. And this is actually at 18 degrees. So this frame is actually designed for a lower camera angle, but I prefer to fly at about 30 degrees. So you can see I've got my camera tilted up there at 30 degrees. And so I need my session to be mounted so it's facing up at 30 degrees. So I've got this mount here. So what I did was I actually just took the original mount. I took the bottom off the original mount and I just meshed it up with another GoPro session mount that I had. And this came up with this one. And a big shout out to Phaser FPV on the Central Coast near Sydney. That's where I get all of my TPU printing done. They've got a service where you can just go online, upload your STL, and get a quote right there on the spot. And then a couple of days later, get your part in the mail. Good service. Right, well, let's get this top plate on and we'll look at some battery mounting. For the battery strap, we've got two slots here, but with the size battery I'm using, the 1100 mAh, you can see that the back one here, it's a little bit going to be a little bit hard to get a battery strap onto there. It's only going to be half on the battery. So I'm just going to use this first battery strap. Okay, so let's have a look at the battery pad now. And this is the battery pad. It's basically just a thin piece of hard rubber. It's not that big at all, and it just goes on there like that. But I really don't like to use that. That's next to useless. What I like to use is this Uma grip. It's a very sticky sort of battery pad and you can just cut it out. Or a piece of 3 or 5 millimeter foam with adhesive backing on it. Okay, so you can just cut the battery pad out with your favorite laser cutter. Or if you don't have one, just borrow a friend's. But seriously, you could even just cut it out with a pair of scissors or a Stanley knife. It's quite easy to cut. And there's the finished battery pad. This one's got an adhesive backing. You can just peel it off. Now you might notice I haven't connected the XT60 connector yet. I always leave that to last. I need to get the battery mounted and so I can see where the connector needs to go and how long these leads need to be. So I'm just going to plug the XT60 in here and just put the battery lead in the position I want it to be, and then just see exactly how long these leads need to be and where that connector needs to sit. So I think I'll just make a mark there, and that's where we're going to need to cut them. Okay, well, this has been a really fun build. I can't wait to get this thing flying. If you've enjoyed it too, don't forget to like and subscribe. I'll see you next time.